So today I'm going to be explaining why the derivative of arcsine is what it is and kind of the process of deriving it. So right off the bat, I have the function y equals the arcsine of u, where u is some function of x. So this could be x squared, it could be e to the x, could be cosine of x, pretty much any function of x that can be plugged in there. So the first step in doing this is to take the sine of both sides. So we're going to have the sine of y equal to u. Because the sine of the arcsine, those two things just cancel out, so you're going to be left with u. Now the really important step here is to understand what this means. So what this means is that we have essentially a right triangle with angle y, because we're saying the sine of y is u, and sine is opposite over hypotenuse. So for this, we have u and 1, because you can think of u as being u divided by 1. So that's what this function really is representing, is a triangle with angle y, where the sine is u, so the opposite is u, hypotenuse is 1. And that's really going to help us later on. So now what we're going to do is take the derivative of both sides with respect to x. So we're going to take the derivative of this side with respect to x, which is going to give us cosine of y times dy dx, which is what we're looking for. And on this side, we're going to get du dx, which I'm just going to simplify that and write it as u prime. So now, if we're solving for dy over dx, the next step to do is divide both sides by the cosine of y. So we're going to get dy over dx equals u prime divided by the cosine of y. Now this is where having this triangle really comes in handy. If you look at this using Pythagorean theorem of a squared plus b squared equals c squared, we can solve for this side length as the square root of 1 minus u squared. So now, since on the bottom here we have the cosine of y, to solve for that, all we need to do is take the cosine of this angle, which is adjacent over hypotenuse. So in this instance, it's going to be this 1 minus u squared, all square root. So what we wind up with is dy over dx equals u prime over the square root of 1 minus u squared, which is the answer for the derivative of this function with respect to x. And this same exact sort of approach can be applied to every single arc function. Arcsine is the simplest, but all of them follow this exact same method for getting the derivative. And that's why the derivative of arcsine is u prime over the square root of 1 minus u squared.